Alright, so today we are going to be learning about direct variation. So with direct variation, this is going to be a specific relationship, which there is a constant ratio, and our ratio that we are going to always have is going to be y over x. And we will most of the time be given some ordered pairs, like down here, and I will explain what I mean by a direct variation. So when we have a direct variation equation, it's going to be written as y equals kx. So when we are looking for direct variation equations, we want our equation to go through the point 0, 0. So we want it to go through 0, 0, which means that our normal y equals mx plus b. If we have anything in our y-intercept spot, then we know that we are not going to have a direct variation. So I'm going to do some examples of these for you, and I'll make sure I do an example. We have a few where we would be able to say that there's a direct variation. Then we also have some where we would not be able to say that it's a direct variation. So when we're looking for k, right here, so we're going to look at our ordered pairs. So when we put 4 over 1, okay, we know that that's going to simplify to 4, okay? So we look at 4 and 1, then we look at 8 and 2, we look at 12 and 3, and 16 and 4. And if you did not already notice, we can notice a pattern between all of our y and our x. So 8 divided by 2 is also going to be 4. 12 divided by 3 will be 4, and 16 divided by 4 will also be 4. So we can then say that our constant is going to be 4. Alright, and then we can set up an equation just simply as y equals 4x. So if we were given our ordered pairs in a table, like say number 3, we can do the exact same thing. Okay, so I will let you guys do number 2. So on number 3 we have a table. So same thing. We have negative 8 divided by negative 12. And we know that that's going to simplify to, if we divide both of them by 4, we get 2 over 3. Now you want to check your other points to see if those will also simplify to 2 over 3. So when we look at these, we have negative 4 over negative 6. We know that that will simplify to 2/3. We have 0, 0. That's where we want to start, so that's obviously going to be one of our points. Then we have 2 over 3. Remember, it's always y divided by x. Okay? So we can say that our constant is 2/3, and our equation would be y equals 2/3 x. All right, so we'll move down to some of the examples at the bottom. So identifying equations. So I'm going to do an equation that is going to be a direct variation. Then I'm also going to show you one that is not a direct variation. So when we are looking at number 5, we can see that we have our constant, which is k, right here. So can we say that this is a direct variation? Yes. All right, but look at number 7. We just have y equals 2. So if y equals 2, that's our equation, which means that we can just have an infinity or a negative infinity to infinity of x solutions. So this is not going to be a direct variation. We don't have that k value right there. Okay, we don't have that right there. All right, all we know is that y equals 2. Okay, So then you can also see on number 9, we have y equals x minus 4. So this is in y equals mx plus b. Remember, we don't want anything in b. So this would also be a no. All right, and let's look at number 13. So the last one we'll look at on here. So we have 5x plus y equals 0. Well, that's in standard form. So what I'm going to do is I'm going to subtract 5x from both sides. Well, then I end up with y equals negative 5x. So now I do have a constant here. So yes, this is a direct variation. All right, so on your second page, we have some graphs that we want to look at and see if we can identify the direct variations. And if we can say that something is a direct variation, we also need to identify the constant. So when we look at number 14, we see that it goes through 0, 0. So now we just need to find out what our constant is and make an equation. So if I start here, I'm going to go up 3 and I'm going to go over 2. So I can say y equals 3 over 2 x, and I know that my constant is going to be 3 over 2. Alright, so number 15. So we aren't starting at 0, 0. So already we can say, oh, I forgot to say yes on this one. So already on number 15, we know that it's not going to be a direct variation because we are not starting at the point 0, 0. So this one is a no. And our answer would just be no. We don't need to go any further. Alright, and then if we go down to the bottom, so we're going to find some missing values. So when I'm looking at my two ordered pairs, so I have a negative 4 over 2 because I'm going to have y over x, right? Y over x. Okay, so I have negative 4 over 2, so I know that that's going to equal negative 2. So if you looked at these and you thought, hey, I may need to set up some proportions, good job, because that's what we need to do. So I'm going to go back to my negative 4 over 2. So I'm going to say negative 4 over 2 is going to be equal to y over negative 6. So then I would cross multiply. I end up with 2y equals 24, which is going to give me y equals 12. Alright, so that is how we would find a missing ordered pair, okay? And I will do one more. So if we had, on number 21, so we have negative 16 over x, okay? Then I'm going to set that equal to 24 over 6. So I end up with 24x equals negative 96. Okay, so then I will just solve that, and I know that x is going to equal negative 4. Okay. So like number 22, we kind of have a word problem here. So if y equals negative 18 when x equals 3, find x when y equals 30. So all we need to do here, I'm just going to rewrite it like an ordered pair. So I'm going to have 3, negative 18, and I'm going to have x 30. So now I will just set up my proportion. So I'll have negative 18 over 3 equals 30 over x. So I then end up with negative 18x equals 90. So if I divide both sides by negative 18, I end up with x equals negative 5. All right, and you would just do the same thing for 23, 24, and 25. So your homework is just to finish these notes and the practice, and I will be checking them.